Dear participants, very good evening. Welcoming you all for another discussion of this international research method workshop on bridging paradigms, scope with mixed research methodology. And yesterday we have the resource person. Today, tomorrow, as well as for the remaining 5 days, Professor Dr. Ambati Rao sir will be taking the classes on the particular sequence of classes. And hope you all enjoyed the yesterday's session. As sir told that he will be uploading all the notes in the drive itself. Hope you people are able to download everything in the drive. And now, without any delay, now let me invite sir to take over the session. Once sir will be complete the class by 7:45. After that, we can go for an interactive session. Thank you so much, and over to you, sir.
Thank you, sir. Thanks a lot. Thank you. Good evening, respected faculty members, research scholars. I'm just starting my session. So today we are going to have two sessions. First session, we are going to have basic understanding of descriptive statistics. And the second session, we are going to have discussion on inferential statistics. So before going to talk about today's session, let me have a brief understanding of what we have discussed in the previous class. Yesterday, we discussed about basic conceptual understanding of some of the important concepts, like what is hypothesis testing procedure, what is the concept of significant values, what is the concept of confidence interval. And we also discussed about interface of the SPSS, and we also discussed about data view, variable view, and how to import the data, how to enter the data manually. And we also discussed about different levels of measurement as a part of yesterday session, right? And I also mentioned that just having knowledge about levels of measurement is going to help us what kind of statistical tests that you're going to use it. Secondly, I also touched upon a little bit about basic assumptions as a part of parametric, non-parametric statistics. That is having understanding about assumptions, having understanding about levels of measurement, help us to choose what kind of statistical test one can use it. So in coming classes, in coming slides, we'll discuss more on each type of test, what is the test is all about it, when to conduct that particular test, and in order to conduct that particular test, what kind of data we require. So we'll go one by one. Okay. So yesterday we have discussed about the entire what you are seeing on this particular slide. Coming to today, as a part of today's session, having understanding about how to enter the data, how to import the data. Today we are going to discuss about certain data transformation techniques. So what are the data transformation techniques? How to do it? We'll discuss. Then by using the sample data set, we'll also discuss about how to create the frequency tables, cross tabulations for the categorical data, like gender, urban area, rural area. If you have ordinal data, nominal data, we call it as a categorical data. If you're having nominal data, ordinal data, we can call it as a categorical data. As a part of statistics, we call it as a categorical data. When it comes to the quantitative data, like interval data, ratio data, we call it as a quantitative data, scale data, metric data. Okay. After completion of the basic descriptive statistics, we'll also talk about how to conduct the normality test, how to conduct the t-test. Within t-test, we have three types of statistical test: one sample t-test, independent sample t-test, paid sample t-test, and if time permits, we're also going to discuss about ANOVA. So these are the things I'm going to discuss for the next 1.5 hours. Okay. I just want you to ensure that my slides are visible and you are able to see my. I keep moving from one slide to another slide because as I'm handling PPT for the sake of some of you, and I'm also practicing as you are following, you're also doing some of it. So please let me know at any time by mistake from my side if I'm not able to show any of my screen. Okay. Now coming to the data management, as you all the scholars, all of you knows that just collecting data is not sufficient. You also need to clean your data. If you're not able to clean your data, without cleaning it, if you start working on your data set, there is a high chance of committing a lot of errors, a lot of mistakes. And forget about committing mistakes. You may not be able to perform any statistical test also. So once we import the data, we have to ensure that you are able to clean the data. Then you'll start entering, preparing various statistical tests. So as a part of data editing, data must be inspected for the completeness and consistency, because there is a high chance that every respondent will answer different manner. If you are giving entire your research tool like this, if you look at my slide right now, I have given age, I have given coding 18 to 24, I have given code 1, 2, 3, 4, 5. Sometimes you might not be giving code. You might be asking them to just enter what is your age. Some people will mention 18. Some people will mention they have write it in words. Some people write it 18 years. Some people write 08. There might be so many mistakes. You might face it. Just take for example marital status. I can write a single capital letter S I N G L E. There is also possibility that I write small letter S I N G L E. The Excel or the CSV format, the respondent, whatever they are going to enter, it is going to take capital letter S I N G L E one word, small letter S I N G L E one different word. So we have to see that in every column, in every row, data there is a uniformity. For example, I'm going to write Tata Institute of Social Sciences, Mumbai. Some people write TIS Mumbai. Some people write only TIS, right? Now, some people write Tata Institute of Social Science. So it is not in your control. It is not in your hand. But only thing is that you should be able to see, you should have to give the glance. You have to go through every column, every row, and you have to see what kind of uniformity you have it. That is point number one. So that it is going to help you to in terms of maintaining consistency. You can able to come up with proper data analysis. Second one, respondent may not answer the question on a marriage or age or annual income or monthly income, whatever may be that. So as a result, you will see that a lot of missing data. There are various scholars says that if it is less than 5%, there are different scholars. Some people say that if it is less than 5%, okay, you can go ahead with that. You can say that out of 100, 96 people, 95 people answered it. That is fine. But imagine that if it is more than 10%, 20%, 30% is that particular question is not answered. Some scholars suggest that you have to remove that particular variable. But there are some scholars, they suggest that you can follow certain missing data treatment. I'm going to discuss about it. Missing value treatment. How to impute the missing values, right? So there are one or two methods I will discuss as a part of it. And you can also see that the coding part, how you're going to give the code. Coding, whatever you decide as a part of your research tool, that coding has to be followed throughout your entire study. It's not like at the time of data collection one, at the time of data analysis, another some other one. If you're able to maintain, if you're able to see what kind of changes that you have made, that is fine. And also certain data transformation techniques, like for example, in this particular case, I collected about age. I didn't give any class interval. I got every person said that 18 years, 20 years, 21 years, 25 years. Now that is quantitative data. I want to convert into class intervals. That is possible. Second one, you have certain question like, for example, question number 9. How often we have experienced physical violence in the last year? So we often use some Likert scale statements like 1, 2, 3, 4, 5. My supervisor suggested me that you need to convert this particular statement into positive statement and negative statement. So I need to reverse code the code. In place of 1, I have to code it as a 4. In place of 2, I have to code it as a 3. In place of 3, I'm going to code it as a 2. In place of 4, I'm going to code it as a 1. So how one can transform the data, because you already collected it, right? But with the help of the software, how we can recode some of the variables. That is also we are going to discuss about it. So let's see a few more options. When it comes, I'll discuss more on it. Now, with the help of the software, with the help of the data that we are going to import, we are going to create frequency tables. The main objective of frequency table is to count the data that you got it. Like you can put it in the terms of out of 50 people, how many people belongs to particular category. We'll basically use frequency tables whenever you want to use univariate analysis, where you have only one variable, like gender, if you have only one variable. Okay. And you can also talk about cross tabulations where you have more than one variable. If you want to compare academic performance based on the gender, or if you want to compare academic performance based on nature of the university, type of the university, or rural area, urban area. So if I'm going to use more than one variable, I'm going to use cross tabulations. The main objective is to see the relationship and to see the differences between different groups, different categories. Okay. When it comes to the percentages, just like in the form of frequency table, one can also present percentages. More than frequency, more than the actual number, layman also can able to understand easily if you're going to use percentages, right? So percentages we are going to create with the help of the data. And we are also going to create, discuss about how to prepare measures of central tendency like mean, median, mode, and measures of dispersion. Okay. I'll also discuss about a couple of charts. Right now I'm talking about theoretical part, then we'll go for hands-on practice. As a researcher, with the help of the software, one can create number of diagrams, number of charts, like one can prepare the bar chart. But most of the time what happens is, we don't see the purpose of the chart. If you ask your PhD scholars, they say that I like this chart, I have selected it. But is there any justification for it? Instead of simply selecting randomly whichever chart you like it, there should be some parameter, there should be some justification why you are selecting particular chart. For example, if I'm having categorical data, I'm going to use bar chart. It can be a vertical bar chart, it can be horizontal bar chart, like gender, nature, ordinal data, nominal data. If you have, I'll go with bar chart. But in case if I'm having quantitative data, like height, weight, okay, annual income, monthly income, okay. If I have any kind of quantitative data, histogram is the right choice for it. Okay. I can also talk about, for example, all of you might be watching cricket, right? I just want to see the run score, current run score, or from the first over to 10th over, how run score is increasing, decreasing, how fluctuations are there, right? For that, if you want to understand, I can use line chart. I can use line chart not only for particular individual, not only for particular cricket team like India. I can also use like India and Pakistan. I can see when India was in fifth over, what is our current run score? When Pakistan in fifth over, what was the current score? So who is performing best? That way. Pie chart, whenever we have some kind of percentages, proportional, just like categorical data, if you have any kind of percentages, proportionals. Basically, if you look at the entire statistics, entire graphs, these are the some of the charts one can prepare it. But every chart has some purpose. Overall, you can see there are four types of purposes. Whenever I want to understand relationship between variables, like a correlation, I'm going to use scatter plot. I'm repeating again. If I want to understand the relationship between two variables, like two quantitative variables, I'm going to use scatter plot. Let me give you one best example. I believe majority of your, at least 50 to 60% of your belongs to them. I believe that you are working. Okay. I just want to know your annual income and annual expenses. If annual income increases, whether annual expenses increasing or decreasing it. So for that, I'm going to use correlation test. In addition to statistical test, if you want to present that particular data in the form of chart, I'm going to use scatter plot. If one variable increases, other variable increasing or decreasing it. So in that case, scatter plot is the right choice for me. Okay. So if you want to see the relationship between the variables, I have scatter plot is the one. If you have two variables, scatter plot. If you have more than two variables, this is called bubble chart. Okay. Now, next one. If you want to see categorical data, like for example, if I want to see the statistics of some variables like gender, I have only one variable. Like for example, I want to talk about type of universities, central universities, state universities, deemed universities. I can say that what else we have? Private universities. If I have only one variable, but in case we have two variables, like type of the university and gender, right? If you have more than three variables, multiple bar chart, right? Secondly, if I'm talking about time period, I'm talking about the number of universities established year-wise. I don't know exact figure right now. How many universities we have as on today? Sometime back, around 3 to 5 years back, uh, around 600 plus 50 universities. Imagine that there are 1,000 universities. I just want to know from the year 1850 onwards, as on today, year-wise, or at least for every 10 years once, how many universities are established? I can go with the line chart. Not only cricket score, cricket match, even this particular line chart is also going to help in that case. If I want to see that particular university of establishment, if you want to compare within two universities, or if I want to compare central universities, state universities, so there are many options are available here. The point that I want to tell you finally, I want to conclude is that instead of choosing any kind of chart randomly, okay, ensure that whether you have categorical data or quantitative data. Categorical data means nominal data, ordinal data. In that case, one can go for bar chart, one can go for pie chart. In case, if you have quantitative data like interval data, ratio data, in that case, one can go for histogram, one can go for line chart. Same thing is reflected here. You can able to see here. Okay. Pie chart, bar chart, different kind of bar charts. You can prepare it. This is nothing but line graph. I'm looking at the clinic 1, clinic 2, clinic 3, year wise. Like as I mentioned about universities or cricket score. Population pyramid, if you're comparing gender, male, female, population wise, that is also possible. This is again a bar chart. I just want to see the geographically how many social enterprises we have. I have collected data from 50 social enterprises. What is the scope of these particular social enterprises? Local level, regional level, state level, national level, international level. I just want to know what kind of fund they're getting. Social enterprises funding sources, angel investors, bank loans. So if I feel that I have more values, more items, I can decide whether I can put it in the horizontal format or vertical format. So it depends on the number of options that you have it. You can able to see whether you want to prepare in the form of horizontal or vertical. As a researcher, how you are able to present in that particular place is looking very, what to say. If you have more number of options, it's always better to prepare vertically. Okay. Next. Let me go with the data, then I'll talk about rest. I request all of you to please open your, I believe that I already mentioned at the beginning. Today I have uploaded a couple of files. The name of the files are qualitative data analysis using SPSS. One point here is that the people, those who not installed SPSS software, he may not be able to open it. Okay. The people, those who installed, they can able to open this particular software directly, this particular data set directly. Those who not installed SPSS, you can't open this particular data set. Okay. Please download this particular data sets. I'm giving 30 seconds time in case we haven't downloaded it. Please be ready with the data. Shall we go ahead? Are you ready with your data set? Any expressions, any one of you? Please send your reactions. Shall I go ahead? I hope you are in the session. Are you ready with the data? Shall I go ahead or not? So what I have to take it? Whether I have to consider you are there with me or not? Anybody willing to say there are 168 people? Either you can put message in the group. Yes, okay. Okay. Now I have opened the SPSS data set that I have given to you all. I just want to prepare the single frequency table. Okay, I want to prepare frequencies, cross tabulations, charts, as well as descriptive statistics. Okay. Now, once you import the data, as I mentioned at the beginning, we are going to prepare some data transformation techniques. We're going to prepare certain data transformation techniques. For example, in my variable view, first try to understand what kind of data we have it. Whenever you're going to work on your data, you should know what kind of data that you received it, that you have it. We have ID of the respondent, we have gender, and we have given coding like 1 for male, 2 for female. Okay. Age, we don't have given any values. And education, we have SSC to PhD, time for reading, facilities. So this is basically data which we have collected from the prison, the people those are spending time in the prison. So we're asking about what kind of facilities they have in the prison, like reading facilities, and how administrators are supporting, are cooperating with them, in which building they are staying, old building, new building, and how many what kind of crimes they have committed, like nature of the crime, rape, violence, stealing, fraud. And we also wanted to know, are they belongs to athlete category, non-athlete category, and drinking status. So rest of the variables I'll discuss when time comes. Okay. So we have a couple of variables, around 18 variables we have. Coming to the data, we have around 50 responses we have. We have around 50 responses we have with us. Okay. Now, when you say that age wise, I have data from I don't have any kind of classifications. Like for example here, age, I'll put it in 0 decimal, go to the data view. I just want to prepare some class interval. My supervisor suggested me that instead of using this particular data as it is, I need to prepare some class intervals. But now I already collected data. At this particular moment, how I'm going to collect the data? I can't go back to the field, right? So what I can do, I can prepare some classifications. So in order to create the classifications, please look at my screen, everyone. Go to transform. Go to transform. There is option called recode into different variables. In order to transform the data of age from quantitative data into qualitative data, I'm going to transform. If you scroll your cursor down, I can see there is option called recode into different variables. Recode, there are two options. One is recode into same variable. Second one is recode into different variable. I don't want to disturb the existing column. I want to keep this particular column as it is. In addition to this particular column, I want to create one more age group. Okay. So instead of manipulating, instead of making changes in this, I don't know what my supervisor is going to tell me next day. So I want to keep this particular data as it is. Okay. So just go to transform. Instead of going to same variable, recode into different variables. Recode into different variables. Now, which variable I want to recode? I want to recode age. The moment I selected the recode into different variables, I got this particular window. Left side of this particular window, I have all the variables that I have used for collecting data. Okay, left side of the window, I have all the variables. I have selected the age of the variable, and you can see that there is arrow mark. Just click on this particular arrow mark. I have transferred, I have moved from age from here to here. Okay. Now here I'm going to create new variable. Name of the variable is, it should be different than existing variable. Already we have one variable name, age. But here, as I mentioned at the beginning of the session, we have to see what kind of data that you have it. Right now, it is showing me age as a nominal data. So just come back, go to the variable view, go to the variable view. If you look at the measure, we need to make changes. Though it won't be problem long term, but if you are consulting some expert or if you are going to give this particular data to your supervisor, they may get angry, they may not happy with your data. So you should change this particular measure. Gender is a nominal data as it is correct. Age is not the nominal data. Age is the nominal data, it is a scale data. Education, it is ordinal data. We have, like, if you look at the values, SSC, intermediate, degree, PG, PhD, means it is an order, right? So that's why it is known as ordinal data. Time for reading, you are asking Likert scale statements. So again, it is ordinal data. Again, we have scale. Again, this is ordinal data. Jail administration cooperation. Again, we have Likert scale. This is ordinal data. Then we have old building, new building. So this is a categorical data. It is a nominal data. Nature of the crime, we have nominal data. Athlete, non-athlete, it is a nominal data. Drinking status, it is a nominal data. We have three categories. And knowledge, it is a scale. Scale, height is a scale. Provision, we have two types of provisions. So it is a nominal data. Number of crimes, we didn't give any values. So it is a scale data. Pre-counseling, before pre-counseling, post-counseling, these are all scale data. We have it. Okay. Now, you can see the symbol. Nominal data means it is going to show you in the form of balloons. I don't know whether you can call it as balloons or you can say that there are three balls, okay, 3 balloons. Ordinal data show you in the form of some like chart, as you can see the bar chart, okay. Scale data, you can able to see the scale, that option itself. Now go to transform, go to transform, go to transform, recode into different variables, recode into different variables, select age, and just click on this particular option. Now here we are going to give the name, different name. We should not give the same name because we already there age as 1. So you are going to age 2. I'll give it that as age 2. Let me age 2, okay. And label age classification, age classification, age classification, okay. I hope I'm not going very fast. Please stop me at any time, okay. So I just want to convert quantitative data into qualitative data. For that, I'm making some changes. So I have given the new variable name age2. Label name is as age classification. Just click on change. As you can see that the moment I click change, we have created new variable. Here, old and new values. You can see that this particular option is highlighted. Just click on this particular option. Just click on this particular option. You'll get new window. Okay. Now it is here it is showing old values left side, new values right side. Now old values, I just want to know first of all, what is the minimum value? What is the maximum value? If you want to create a classification, we should be able to understand what is the least youngest person in our respondent and eldest person in our respondent. So in order to understand that, what I'll do, I'll go to analyze. Please come back. I'll go to analyze. Go to descriptive statistics. Go to descriptive statistics. There is option called descriptives. There is option called descriptives. Select age of the respondent and take it to the right side and go to options. Go to the options. Here I want to select minimum value, maximum value, minimum age, maximum age. Rest of the values are not helpful for me at this moment. Okay. Minimum, maximum. Okay. Just continue. Okay. Now we have 50 respondent. Out of the 50 respondent, youngest one is 21 years. That is the minimum age is 21. Maximum age is 61. So having knowledge about minimum age and maximum age is going to help us how to give the classification. Now 20 to 60 means hardly, I can give four classifications, or I can also give two classifications. Depends on the sample size. You can able to decide how many categories that you want to have it. Okay. Now I understood 21 is the minimum, 61 is the maximum. Go back, go to transform, recode into different variable. I'm selecting age. Here age 2, age classification, age classification. Click on change. And now I'm clicking on old and new values. Here I'm giving the range. I just want to click on the range here. We have seen that 21 to 21 is the minimum, 21 is the minimum, and 61 is the maximum. If you want to say that 21 to 30 should be considered as a 1. Please look at my slide. I hope this particular slide is visible. I'm giving the range. I'm giving the range. I want my system should consider old values, range 21 to 30, right side 21 to 30 should be considered as 1. After giving this particular one, click on add. Click on add. Now you can see that 21 through 30 is considered as 1. Next one, 31 to 40. You should consider as a 2. Just click on add. Next one, 41 to 50. It should consider as a 3. 51 to 60. It should consider as a 4. And highest, whichever is there above 61, range value through highest. Which one is there more than 61? It should consider as a 5. Add. Now continue. OK. Recode age. We have done with the performance. If you want to see the actual output, if you want to see the actual output, please go to the variable view here. Earlier, we had only 18 variables. We had age serial number 3, and we got the new age, new variable age 2. That is age classification. Just go to the data view. Please look at the bottom of the window. Left side of the window, there is option called data view. If you open the data view and go to the last column, go to the last column. We got 1, 3, 4. Right now, we don't know what is 1, what is 2, what is 3, what is 4, what is 5, right? So come to the values here in the variable view. Go to the variable number 19. Just click on values here. 1 is nothing but 21 to 30. So we have to feed again. We have to tell to the system that what is 1, what is 2, what is 3, what is 4 again. So we have to again give the code here once again. 2 is nothing but 31 to 40. 3 is nothing but 41 to 50. 4 is nothing but 51 to 60. Fifth, nothing but 61, more than 61 or greater than 61. Whatever you want to type, you can type. Okay. More than 60, you can say more than 60, you can add it. Okay. Click on OK. Now we have added values here. Now come to the data view. Come to the data view. We have given the values. And if you want to see what is 1, please look at my cursor. On the top ribbon bar, there is option called help. Under the help, there is one menu, value labels. Just click on it. I can able to see what is meant by 1 here. Like it is 21 to 30 here. Similarly, here we have under the crime, rape. What is rape? How we have coded here? We have coded rape as 1. So this particular window, this particular option under the help ribbon bar, it is going to help us to see how we have given coding. Okay. Is it clear so far? Do you want me to repeat any of the steps that I have followed till now? Shall I go ahead with the next? Anyone say yes, no, or you can type in the chat. Is there any requirement of repetition of any of the step? Is it clear? Shall I go ahead? Yes, okay, thank you. Coming to the next part. I'm sharing my screen again. Now, so we have converted quantitative data into qualitative data. One. Second one, let me see if there is any Likert scale statement here. Come to the data variable view. I have Likert scale here, like strongly disagree, disagree, and okay. Now, as a researcher, you might be having more than one statement Likert scale. In this particular data set, I have a couple of questions which are I'm trying to collect the data from the prisoners about their attitudes or perceptions about support services provided in prison. Like we have sufficient time in jail for reading. The facilities are available in the jail to enhance the educational level. So we have three questions, three Likert scale statements. Now, as a researcher, I don't want to prepare for every question one chart or one table. Like how many people said that strongly disagree with the statement of we have sufficient time to read. I just want to know what are the positive feedback, what are the positive feedback and negative feedback of the prisoners. So I want to get the mean score for all the three statements together. I'm repeating again. Instead of taking each item separately and preparing the single frequency table, I want to calculate the mean score. I want to consider attitudes of the prisoners as a one variable. I want to come up with one variable. I want to get the mean score for these three items. Okay. How to do that? I hope concept is clear. There are three items. By using these three items, I'm trying to measure the attitudes of the prisoners, how are they satisfied with the support services provided in the jail or in the prison. Okay. I want to club these three statements together under the name of satisfaction of the prisoners. Okay. In order to do that, go to transform. Go to transform. There is option called compute variable. There is option called compute variable. There is the first option. Just click on it. Here, I just want to create the new variable. Name of the variable is satisfaction. Satisfaction level of the prisoners. I'm giving the variable name. As you can see that here, serial number 20. I'm going to create new variable. Name of the variable is satisfaction. Just click on type and label. Here I'm going to give the full title, satisfaction of the prisoners. PRISON. Prisoners. Okay. It is a numeric value. This is a numeric. This is a numeric. Okay. Just continue. Now, under this particular satisfaction variable, I want to club three items. I want to club three items. First one is by clubbing these three items, what I want to get it? I want to get the mean score, right? So for that, I need to see where is the mean. If you look at the function group here, if you click on all the functions will be visible here. Here, if you go here, you can able to see there is option called mean. You can able to see there is option called mean. Just click on it, select it, and click on this particular button. I'll repeat once again. I want to create a new variable. Name of the variable is satisfaction. I'm going to club three items. I am going to club three items. By clubbing three items, I'm going to get the mean score of that particular satisfaction. Okay. For that, we have to see the function group. Here, there is option called all. If I click on all the functions that are available, that will comes here. And you have to choose mean, that I want to get the mean. I have selected the mean and I just click this particular arrow button. Mean is open here. Okay. This is one option. This is one way. Now here, wherever there is a question mark, wherever there is a question mark, I'm going to add that particular statement. First statement is, we have sufficient time in jail. Just select it, add it here. Go to the next. The facilities are available. Next, comma. Jail administration is very cooperative, comma. Now, just click enter. I got the satisfaction score. Go to data view. Look at here. By combining three items, I got fourth variable, that is the name of the variable is satisfaction. Now I can see by using this particular word, I can compare with the gender wise, whether male prisoners are satisfied or female prisoners are satisfied. Okay, so I can able to see that work. Let me repeat again for the sake of others. We are going to go to transform, compute variables. We are going to give the name of the variable, that is satisfaction, and we are going to type the label. As I want to select the mean, I'll come here, I'll select the mean option, I'll click here. The moment I click it, I'll get the mean formula here. Within the brackets, wherever there is a question mark, in place of question mark, I'm going to keep the particular items that I want to keep it. Here, if you look at here, I added three items: time for reading, facilities at the jail, administrator cooperation. That's all. After selecting all the three items, keep your cursor outside the parenthesis button. After selecting the respected items that you want to include, that you want to club under this particular satisfaction variable, keep your cursor outside the parenthesis button. Just click on OK. Just click on OK. If you click on OK, you'll get this particular variable. Name of the variable is satisfaction. Come here under the variable view. Now we got the satisfaction here. Now there are two ways. There are two things here. One can do that. I got the mean score. I got the mean score. It is, I can see that highest score is 4.67. 4.67, 4.67, highest score, 4.67. And the least score is 1.3. Least score is 1.33. Okay. Again, I can convert this particular data into qualitative data. Like I can say that, for example, I can divide this particular data into low satisfaction, medium level satisfaction, high level satisfaction. Okay, that way also I can able to prepare it. Okay, I can also prepare two categories: satisfied. I can also prepare like highly satisfied, strongly satisfied, not at all satisfied. It's completely up to the scholar how we can again you can convert into qualitative data. How again you convert into qualitative data. So there are so many data transformation techniques are there. It's all about what is required as a part of your analysis. What is required as a part of your analysis. Tomorrow, if time permits, I'll be talking about structural equation modeling. I'll be introducing, if some of you might be interested in measuring attitudes, perceptions as a part of HR, as a part of management, in general, as a part of psychology, or in social work interventions, social science related issues. So how you're going to handle the scales items. Tomorrow I'll give you more explanation with the help of another software that is SmartPLS. Okay. So these are some of the transformation techniques. Are you missing anything? Missing values. Okay. Last one. Oh, before going to the next session, that is missing values. Right now, just look at, I'm deleting some data. Let me save first. I'm deleting one data. Please look at my cursor. I'm deleting data, like for example, age 1, first respondent I have deleted. I have deleted. Second respondent I have deleted. Third respondent also I have deleted. I have deleted responses. Okay. Now I have some missing values. Out of 50, 3 people that didn't responded. So it won't make any difference for me. I can go ahead with conducting this particular data. But imagine that more than 10% of the respondents not answer this particular question. My supervisor is saying that as there is more than 10 people, they didn't answer it. We have to delete this particular variable. But this particular variable is one of the most important variable for me. If I delete this particular variable, I'm not able to come up right combination of data analysis. Okay. So I don't want to delete it. But at the same time, I don't want to have missing values in the data set. So how to solve this particular problem? Okay. So in that case, I request all of you to please look at my cursor. Go to analyze. Go to analyze. If you scroll your cursor down, I can able to see there is option called missing value analysis. I can able to see there is option called missing value analysis. Just click on it. Just click on it. Left side of the window, this is a new window. That is okay, missing values window. Left side of the window, we have all the variables that we have as a part of our study. Right side depends on the type of data that we have it. Like for example, we have categorical variable that is nothing but nominal data, ordinal data. Quantitative variable that is nothing but interval data, ratio data. For example, age is the scale, which are all coming under scale. They comes under quantitative data. So I want to treat missing values for the age. Okay, just click on it. So I'm looking at only one variable, age. Go to patterns. There is nothing to do. Descriptives, nothing to do here. Now, there are a couple of options how to handle this particular missing data. One is regression. One is EM. Just go to regression. I'm repeating again. There are a couple of options are available. Just go to regression. The moment I click on the regression, this particular regression menu is activated. This particular regression menu is activated. If I unselect regression, it is not visible. If I select regression, this particular menu is activated. Just click on it. In this particular option, I'm going to select save completed data. I'm asking give me completed data. Means other than this, what I have right now, I want completed data set by filling these 3 columns also. That particular data set name should be demo. Demo, we have so many. Demo, I have given a new name. For this particular data set, I'm giving the new name. Continue. Name of the new data set is not valid. Okay. Demo. Continue. I just gave only demo. Click on OK. Now look at here. Let me see the data set. Look at my desktop, please. Look at my desktop. I hope my desktop is visible. There is a file name demo. If you look at my desktop, there is a file name demo. I'm just opening this particular file. There is some mistake. Look at here, date. Look at this demo, the file that I got it. If you remember correctly, respondent number 1, respondent number 2, respondent number 3, I had deleted it. But after treating the missing values, I got the figures for it. Now somebody can ask me, sir, how it has taken it? It has taken the mean value. It has taken the mean value, means it has considered the entire total score divided by 47. If it was looking at it is predicting overall score, how responses we got it. Based on that, it has given the mean value of it. Okay. Respondent number 1, 24. Respondent number 2, 23. Respondent number 4, 334. So based on the existing values, it has given some imputed data. So majority of the scholars, instead of deleting your data set, just because more than 10 respondents are not answered your question, because that particular variable is very important for you. So here you can able to fill this particular data as per your requirement. Okay. I hope it is clear how to treat the missing values. Now, you want to go for a break? Shall I go ahead? Is it clear first? Am I clear so far? These are the very important data cleaning, data transformation techniques one should know before handling your data set. Okay. Time is 6:58. Are there any questions? Or you want to go for break like yesterday? Or shall I continue? Binit sir, are you here? Are any of the organizing committee members? No response. So I don't know what to take.
Sir, please continue, sir.
Continue, sir. Yes, yeah, please. Okay. I'm sharing my screen again. Okay. Now, the first session is all about certain data transformation techniques we have discussed. Now, we are going to create frequency tables, cross tabulations, and charts. Go to Analyze. Go to Analyze. Descriptive Statistics. There is a first option called Frequencies. Select it. I want to see the gender of the respondent. I have 50 respondents. Out of 50 respondents, how many people belongs to male category? How many people belongs to female category? So I selected gender. Just click on this particular option. Go to statistics. I just want only sum. I don't want mean, median, mode. Okay. For the categorical data, we don't require mean. We don't require median. Okay. I just need sum. Just continue. Along with the table, along with the frequency table, I also wanted to have chart. As it is categorical data, I can go with the bar chart. I can go with the pie chart. Let me go with the bar chart. I also wanted to prepare, instead of frequency, I want to prepare percentages. Continue. Okay. Look at here. There are total 50 respondents. Out of 50, 27%, 27 people, that is 54% of the people belongs to male category. 46% of the people belongs to female category. Now, the valid percentage, cumulative percentage is not required, right? So what I will do, I can copy this particular data. I'm selecting this particular data with the help of the mouse. I'm keeping my mouse cursor here, right click. I can copy directly, but I want to copy it as in the form of Excel worksheet. I want to export it to an Excel worksheet, or I want to make some changes in the Word document. So I can select it as plain text. I want to take it as an image. Like for example, click on image. Let me open the Word document. Now, when I select the image, when I copy this image, I can't make any changes here. I can't make any changes. So what I will do, instead of image, I'll select it as, plain text. See the difference? Every time I'm not going to perform. See, look at this here. Plain text. I think I have selected again image only. Plain text. So it will come like this. Now I'll show you one more alternative way. Just copy it. Just copy it. Now here also you can make changes. So this is the most easiest way. So instead of going to image, instead of going to anything, just select that particular table that you want to copy. Right click, click on copy. Simple one. So you can make changes. Like for example, I can delete these two columns here. Okay. I can delete it. I can make beautification. So I can able to select this, what are the format I want to make it. I can make changes. You can explore it later on. What else you can do with the help of the uh, changes, with reference to changes. Okay. Now next one. Along with the table, I also got the chart. Now I want to make a lot of changes here. So if you want to make changes with the output that you got it, what you can do, just keep your cursor on the chart, double click. I'll repeat it once again. I don't want to take this particular chart as it is. I want to make changes. Like for example, I want to add data labels. I want to add legend. I want to make changes in the title. I want to make it more beautiful, right? For that, what I will do, I'll keep my cursor here, double click on it. The moment I double click, chart editor will open. Chart editor will open it. Let me maximize it. Now here, in order to make the beautification, what else I can do? I can see I'll keep my cursor on the right side. I want to add title. Title is already there. I want to add data labels. Show data labels. See that I have shown the data labels. I can drag and drop it, change it here also. I can keep it on top. I can keep it on top. Now number format. Here right now it is showing the decimals. I don't want to show the decimals. Okay. Apply. So I removed the decimal. Chart size. If you want to increase, decrease. Right now I'm decreasing it. Apply. See that? I want to make some colors for the chart. Okay. Chart size. I want to apply some colors. So there are so many options are available, just like how you do in Excel sheet. Only thing is we need to spend some time. We need to explore it. Okay. Like shadow, 3D. There are so many options are available with us. Okay. This is one way how you can make changes. Once you make the changes, just right click, copy chart, open your MS Word document, right? Just copy it. Okay. So what are the changes that you want to make it? You can able to make changes in that case. Okay. This is one option. Next one, I want to create the cross tabulation. In order to create the cross tabulation, go to analyze, descriptive statistics. Right side of the descriptive statistics, I can see there is option called cross tabs. I can see there is option called cross tabs. Just click on it. I want to see the association between gender and athlete and non-athlete category, or gender and nature of the crime they have committed. Okay. So I have selected gender. You can choose row wise, column wise. Nature of the crime committed, I'm keeping column wise. So I want to see the relationship association between two variables, two categorical data. Okay. So I have row wise one variable, column wise one variable. I have selected it. Go to statistics. Here we are going to do nothing. Go to cells. I just want to see only observed values. And I want to see how total percentage. I want to see the percentage as well. Click on continue. Okay. Look at this particular figure. So we got the two tables. First one is case processing summary. Basically, it is giving overview of your data. It's showing that I have 50% response from 50 people and there are no missing values, zero missing values. Second one, it is actual cross tabulation. Row wise, I have taken gender, male, female, and column wise, I have taken nature of the crime like rape, violence, stealing, fraud, like this. Okay. So this is how one can prepare the cross tabulation. Some of you might be thinking, sir, how whether I can use more than two variables. Yes, but only thing is you can use more than two variables. But you can see whether the table that you're going to prepare, the table that you're going to present it, as the reader, as an examiner, how your readers are going to feel comfortable. By looking at your table, you should not give them chance to read your data analysis. Means it should be self-explanatory. Whether it's a chart, whether it's a table, people by look they should be able to understand what you are trying to convey. Now the best part of cross tabulation when it comes to more than two variables, in this particular case I have gender only two categories, male, female. Nature of crimes, I have four categories. It is manageable. But if I'm going to add one more variable, if that is going to have two more categories, let's see, for example, go to analyze, descriptive statistics, cross tabs. In addition to gender and nature of the crime, I just want to know whether they have drinking. What is the drinking status? Are they currently drinking? Are they stopped drinking? Okay. So just click here. Okay. Just okay. Now see here. There are 2 points that I want you to note down here. One is my sample size is very less. That is 50. One of the most important part of preparing cross tabulation, or maybe further, if you want to go for a chi-square test, in each cell, for example, this is called cell, right? 5 is a cell, 3 is in one cell. This is column, this is column, this is column, this is row, this is row. But this is called cell. As a part of the cross tabulation, 80% of your cells should have minimum 5 count. 80% of your cells should have minimum 5 count. In case if your majority of the cells or more than 20% of the cells have less than 5 count, this particular data may not be valid for coming with any kind of conclusion. If you look at this particular table, I have 2, 3, 0, 1, 2, 2. There is one very less number of people, less number of cells. I have more than 5. Here 5, here 5, 6, here 8. Majority of the cells I have less than 5 count. Here 11, 9. This is total. I'm repeating again. Whenever it comes to preparing the chi-square test, or even for that matter cross tabulation, please ensure that don't have so many variables at a time in the single data. So it is going to, if your sample size is good enough, if you can able to ensure that more than 80% of your cells have more than 5 count, so in that case you can go ahead with that. More at a time you can use more than 2 variables. Second, that is first point. Second one, this particular table sometimes may be complicated because I have 4, three types of drinking hobbies: current drinker, former drinker, abstainer, gender, male, female, nature of crime. So the data analysis also will come very, it won't come properly. I may not be able to analyze in the right manner. So looking at the number of variables that you have, number of classification that you have it, based on that you can decide whether you want to go for more than two variables cross tabulation. Okay, this is one important point. Okay, next, I want to prepare the descriptive statistics. Go to analyze descriptive statistics. Under the frequencies, there is option called descriptives. Now, when it comes to the descriptives, we need to have quantitative data, like age is one. Satisfaction of the prisoners we have. Okay, go to options. I want to see mean value. Okay. I want to see the standard deviation value. We go on OK. So when it comes to the quantitative data, there are total 50 respondent. Average height of my 50 respondent is 34. Minimum value is, minimum age is 21. Maximum age is 61. Minimum age is 61. Maximum age is, minimum is 20. Maximum is 61. Whereas when it comes to the mean value, it is 34.85. 34.85. When it comes to satisfaction, minimum satisfied prisoners 1.33, maximum satisfied, what is this? Maximum score is 4.67. Mean level is 2.9, means average, on average 3, neutral. You can able to satisfaction score. Okay. So this is called descriptive statistics. One can prepare. Go table for. Okay. Small one. Now, next one. I'll show you one or two tables, how to analyze the data. I know that many of you have good writing skills, good interpretation skills, but at least if there are very young scholars, from their point of view, once we prepare your table, how we are going to analyze it, how we are going to report it as a part of your research report. Let's take, for example, in this particular table, I have gender. Here I'm going to analyze. Table 1 indicates that more number of respondents were male, while female represented only 42%. However, the study revealed that there is not much significant difference found in the gender of social entrepreneurs in pursuing social entrepreneurship as their career. Actually, I have collected this particular data from 50 social entrepreneurs. I just want to know how many of them launched their ventures. Now, looking at this particular percentage, I found that there was no much significant difference between the male and female here. Okay. Further, with the help of the existing literature, the results are in contrast to the findings of the existing study, which indicate that social and cultural factors affect the involvement of young women in entrepreneurship. Therefore, it is a positive sign that more women are engaging in the field of entrepreneurship in the current study. Okay. So this is how this is one of the way you can able to write it. Second one, when it comes to the cross tabulation, earlier table I was talking about only about gender. Now in this cross tabulation, what I did, I converted year of establishment of social enterprises, looking at the minimum value, what is that? Minimum and maximum, like 1991 and 2017. 1991 to 2000, I have taken one class interval. 2001 to 2010, one class interval. 2011 onwards, one class interval. So here I'm looking at, in this particular time period, how many people belongs to male category or how many people belongs to female category established their ventures. The study found that interestingly, as compared with the males, female founders, female social entrepreneurs are female respondents are the first one who established their ventures. This is as a part of my selection of the respondent, as a part of my data collection. I'm not generalizing it here. Based on the sample that I have selected, based on the availability of sample, there are four enterprises which are established in the year 1991 to 2000. But all the four, that is all four respondents are belongs to female category. So I'm able to explain. So, however, the study revealed that there is no much significant difference. That is one. Further, the table also indicate that large percentage, majority of the respondents, that is nearly 80% of the respondents, established their social enterprises in the last 7 years alone, that is after 2011 onwards, followed by 14%. When the establishment of social enterprise was compared with the gender variable, there were more females who established their social venture in the time period of 1991 2001. Further, you can explain later on. It all depends on what are your interpretation skills that you have it. Okay. If you look at this particular chart, have taken age group, have taken gender, okay, and I have also taken one more variable. Not only cross tabulation, that is more than two variables. Even while preparing the chart, you can take more than two variables. But the point is that I have prepared this particular chart with the help of the Excel. There may be so many data visualization tools, but when it comes to bar chart, pie chart, or charts point of view, nobody can able to beat Excel because Excel itself is advancing, right? So we have so much of beautification one can do with the help of the Excel sheet. Okay. So this is all about descriptive statistics, frequency tables, cross tabulations, and all. Okay. Now, let me move to the next one. Okay. If there are any questions, please let me know so that I can answer it. Otherwise, I'll go to the next one. Good evening, content, please. Okay. So today, as a part of the test, we are going to discuss about t-test. Within t-test, we have three types of statistical test. One sample t-test, independent sample t-test, paid sample t-test. All the tests are nothing but comparison-based test. We are going to compare. It can be with the groups. It can be with different types of comparisons we are going to carry. First one is one sample t-test. What is one sample t-test? It examines whether the mean of a population is statistically different from known or hypothesis value. Means, as a part of one sample t-test, we are going to compare mean of a population whether it is statistically significant different from known or hypothesis value. Now here, as a part of this particular data, we have hypothesis. The mean height of the prisoner is equal to 66.5. Here, the mean height of the prisoner is equal to mean height is nothing but sample height. Let me tell you here. As a part of one sample t-test, we are comparing population mean with the sample mean. We have population mean. We are getting this particular population mean from many sources. Like it can be like Government of India report, or existing literature report, or some scientific procedures report, or somebody published existing report, or Government of India census report. Let's take, for example, as a part of our hypothesis, we are talking about the prisoners. Now, for example, I am coming from Gujarat National University. Okay. One of my faculty member, they have conducted study all over India. They have collected data from all the prisons in India. All the prisons in India. They collected data from all the prisons in India. They collected data about height of the prisoners. Height of the prisoners. One of the variable is height. Okay. Now imagine that they might have collected data from around 2000 people. I'm not sure exactly how many prisoners are there as on today. Hypothetically, as a part of all over India study, they collected data from 2000 people. Average height of 2000 people is 66.5 inches. Okay. With reference to Indian context, entire throughout India. Now, I belongs to Gujarat. Okay. I can't collect the data from the all the prisons. So what I did, I collected data from 50 people. I collected data from 50 people. This 2000 is nothing but population mean. This is 2000 nothing but population. This is 66.5 is nothing but population mean. I'm repeating again. 2000 is nothing but the population. 66.5 is nothing but the population mean. Now, when it comes to the sample mean, I collected data from 50 people and I found that an average height of prisoners in Gujarat, it can be 66.5 or it can be 70, it can be anything, right? Now, I just want to compare this particular mean with this particular mean. I just want to see are there any differences. Population mean is 66.5 and the sample mean, hypothetically, I'm saying that 70. And we got the difference, how much? 3.5. I can able to see mean difference is 3.5. I just want to know the difference has happened by accident or whether it is statistically there is a significant difference between population mean and sample mean. I just want to see the difference, the mean difference between population mean and sample mean. Is it statistically? I just comparing between population mean and sample mean. Okay. So in that case, I'm going to use one sample t-test. In that case, I'm going to use one sample t-test as a part of my research work. One sample t-test is also known as single sample t-test. Okay. Now this is fine. So far, I believe you are able to understand that if you want to compare population mean with the sample mean, you are going to use one sample t-test. But what about data requirement? What kind of data that you need for conducting one sample t-test? I required only one variable. That variable must be continuous data. Means that variable must be quantitative data, like scale data. It can be interval, it can be ratio. It can be interval or it can be ratio data. Like for example, we have age, we have satisfaction, right? This all comes under quantitative data. We also have height. Scores on the test variables are independent. Yesterday I mentioned it. We are not going to manipulate the data. Every respondent have their own data. Okay. So this is the most common assumption of every statistical test. Random sample of data from the population. I collected data by using random sampling. That is also one of the requirement of uh, going for parametric statistics. Another most important part is I need to check whether my data are distributed normally or not. Yesterday I already mentioned what is normality distribution. Today I'm going to discuss with the help of the statistical test. Okay. Along with the normality data, I also need to see whether are there any outliers. Like for example, are there any responses which are deviant from the existing data, from the mean data. Okay. So we have continuous data that is nothing but height. This will be taken care at the time of data collection only. Serial number 2, it will be taken at the time of data collection only. Serial number 3, this is also as a part of your data collection only. Serial number 4 and 5, it will come once you collect the data, once we complete the data collection. Let's see whether we have our other data is distributed normally or not. Okay. So what is the procedure to conduct normality test? In order to conduct the normality test, there are so many options are available. But one point is that it is not mandatory that you have to use every option that is available. We have to use one of them. If you are using master dissertation, you have less number of variables. You can use couple of normality tests. But as a part of PhD, you might be having more than 20 variables, 30 variables, or more than 50 variables. In that case, just one type of normality test is enough. Second point, we are going to conduct the normality test only for quantitative data. That is nothing but scale data. That is nothing but metric data. If I have gender, I don't need to conduct normality test. If I have like rural area, urban area, if I have data like uh, higher education, lower education, high income, low income, I don't need to conduct normality test. We have to conduct normality test whenever we have interval data or ratio data that is called continuous data. Okay, like age, annual income, and all. Okay. As a part of normality test, one can also use K-notes and kurtosis values. One can use Sperry-Wilkie test value. One can use box plot value. Box plot is nothing but mid value, midpoint. Midpoint. Histogram. Yesterday we discussed about bell-shaped curve, right? Let me show you a couple of options. One of the most important tests which I recommend for conducting normality test is that Sperry-Wilkie test. Okay. So in order to conduct this Sperry-Wilkie test, we are going to frame our hypothesis. Here I'm saying that the sample is drawn from a normally distributed population. As a part of my null hypothesis, especially normality distribution of the data, especially as a part of normality testing of the data, my null hypothesis is always the sample is drawn from a normally distributed population. Whereas alternative hypothesis, the sample is drawn from a normally not distributed population. Now, I'm going to conduct the normality test. If my threshold value is less than 0.05, if my threshold value, that is a significant value, if this particular value is going to be less than 0.05, I reject the null hypothesis. It means if I get less than 0.05, I'm saying that my data is not distributed normally. I'm going to reject this statement. I'm going to reject this particular statement. But if this particular value is greater than 0.05, we fail to reject the null hypothesis. It means the data that I collected, that data is distributed normally. As a researcher, when it comes to conducting normality test, our p-value should be greater than 0.05. When it comes to conducting normality test, our p-value should be greater than 0.05 so that it shows that our data is distributed normally. Please open this particular same data set. We have variable height is here. Okay. Let me go to analyze. Let me go to analyze. Before conducting one sample t-test, I just want to see whether my data distributed normally or not. So for that, in order to conduct the normality test, this is the most common test one has to conduct before conducting any parametric statistics. Name it correlation, name it regression, name it ANOVA, name it any type of comparison-based test. If we are going to use parametric statistics, we have to conduct normality test first. Okay. So go to analyze, descriptive statistics. If you scroll your cursor down, there is option called explore. In order to conduct the normality test, go to analyze, descriptive statistics. There is option called explore. Just click on it. Now, left side of this particular window, I have the variable. Name of the variable is height. Name of the variable is height. I have selected this particular variable. I am going to keep it under dependent list. I'm going to keep this particular variable under dependent list. Just click on this particular arrow. Go to statistics. I want to see the descriptives. I just want to see are there any outliers or not. Okay. I want to see the descriptives. I also wanted to see, are there any outliers? Continue. Go to plots. I just want to prepare the histogram. Like yesterday we have done the bell-shaped curve. I want to prepare the histogram in the form of plot. I want to conduct the normality plot with the test, that is a Sperry-Wilkie test. Continue. Go to options, nothing to do here. And here it is asking what you want to display. Whether you want to see only statistical test results or you want to see only plots. I want both. I want to see the both. Okay. Just click on OK. Now, first one is we got a lot of data. I conducted only one test. Name of the test is normality data, but we got a lot of outputs. But you don't need to, it is not required for you to report all the tables because everything is talking about whether your data distributed normally or not. You can take one of the findings, like I can talk about descriptives. Okay, I can talk. Mainly, we need to focus on test of normality. As a part of test of normality, as per our null hypothesis, what is the p-value here? P-value is 0.172. Is it greater than 0.05 or less than 0.05? Anyone? Is it greater than 0.05, less than 0.05? Any of the scholars are interested to answer that? Greater than 0.05. So how to conclude it? Whether our data are distributed normally or not. As for this, Professor Jagadev, yes, normal. How it is normal? As this particular p-value is greater than 0.05, we can say that our data are distributed normally. But in case, if this particular value is less than 0.05, it means our data is not distributed normally. We cannot go ahead with conducting parametric statistical test. We have to go for alternative statistical test. Okay. Now, as a part of the parametric statistical test, it is mandatory for us to see whether our data are distributed normally or not. So just quoting this particular figure is sufficient to go ahead with further statistical test. Okay. Second one, same data, it is presented in the form of histogram. You can see that we are able to get the bell-shaped curve. Though there are a couple of disturbances, overall we got the bell-shaped curve. It means our data, it is greater than 0.05 means our data distributed normally. Okay. Similarly, we also have normal QQ plots. This is a diagonal line. Our data is supposed to be clustered around this particular data on this particular line. There are certain values which are deviant, but they are not affecting the normality of the data. This is the QQ plot. It shows how our data are distributed. This is the box plot. Here we don't have any outliers. Let me show you one outlier. Right now, we don't have any values here. If you observe here, on top and bottom, we don't have any outlier. Let me go to my data set. With reference to height, look at the first row. In place of 66.92, I'm making change it as 111. Okay, I've made changes. I have manipulated the data. Go to analyze. Go to descriptive statistics, explore. Okay. See here, my p-value is less than 0.05. Just because there is one outlier. In place of 66, I have mentioned 111. It is very high level. Okay. Now, my p-value is less than 0.05. Means my data is not distributed normally. Look at the histogram. How it came. We didn't get the bell-shaped curve, right? Not at all. This is like, see the tail, right tail, how it is. Look at this Nara QQ plot. This is something here, 111. Look at this box plot. This is called outlier. This is called out. Because of this particular one respondent, I'm not able to fulfill the criteria of normality distribution. Now the question is what to do. The question is what to do. If your sample size is big enough, you can delete this particular outlier. I'm repeating again. If your sample size is big enough, you can delete this particular outlier. Okay. Otherwise, you have to increase, you have to collect more data. So these are the two options. I don't know whether it is feasible at the time of writing your report, going again to the field and collecting data. So you and your guide can decide whether to delete this particular respondent. Of course, if you are going to manipulate, nobody can check it. That is a different case. But these are the two options that are available. Let me go back and change it. This particular data set, that is 66.92. Okay, let me save it. Now again, if I conduct it, I got 1.72. My data is distributed normally. So after fulfilling the criteria of my data distributed normally and there are no outliers, I can go ahead with conducting one sample t-test. Okay. So in order to conduct the one sample t-test, go to analyze. If you scroll your cursor down, I can able to see there is option called compare means. Compare means. Right side of this particular window, there is one sample t-test. The right side of the window, there is one sample t-test. My test variable is height. Okay. Now my population mean is 66.5. My population mean is 66.5. That is nothing but test value. That is nothing but test value. Okay. So I have to give the test value. Go to options, 95% confidence interval. Click on OK. Look at here. There are two outputs, two important outputs. We have total 50 respondents. Out of 50 respondents, we have mean height is 67.35. An average height of 50 people, 67.35. Okay. Now, I just want to know there is a difference between population mean and sample mean. Population mean was 66.5 and sample mean is 67.35. And we got 0.85 difference. 0.85 difference. It means not even 1 point, not even 1% difference. But I just want to know what are the differences that happened it. Are there any statistically significant difference between mean and sample mean and population mean? For that, the p-value, I need to see that. If my p-value less than 0.05, it indicates that there is a significant difference between population mean and sample mean. However, if I look at my p-value, it is greater than 0.05. It means there is no significant difference between population mean and sample mean. Okay. Now, next, please go to the next one. Independent sample t-test. In case of one sample t-test, we are comparing population mean with the sample mean, or sample mean with the population mean. Okay. We had only one variable, that is height. Now, when it comes to the independent sample t-test, whenever we have two independent groups, let's take for example, here I'm trying to compare. I'm saying that there is no difference in mean happiness score between male and female prisoners. I'm looking at two independent groups. They're nothing but male group, female group. I collected data from 50 prisoners. We have male respondents, female respondents. I have only two groups. That is one variable. Second variable is mean happiness. That is dependent variable. That is quantitative variable. Okay. In that case, I can go for independent sample t-test. But imagine that as a part of my respondent, I have male, female, transgender. I have one more category, third category. In that case, I cannot conduct independent sample t-test. If I have more than two independent groups, I have to go for ANOVA test. This is the only difference. Difference between independent sample t-test, ANOVA test. Whenever we have two independent groups like rural area, urban area, I can go with independent sample t-test. But in case if I have rural area, urban area, semi-urban, in that case, I have to go for ANOVA test. So my hypothesis is that there is no difference in mean happiness score between male and female. So here, as a part of data requirement, I need two variables. Whenever I want to compare two independent groups, I'll use independent sample t-test. As a part of data requirement, I need two variables. One variable is dependent variable that must be interval or ratio variable. Second one is independent variable. It must be categorical data. It means it can be nominal data or it can be ordinal data. Okay. As we discussed earlier, independence of observation, random sampling, normality distribution. I already shown you how to discuss, how to prepare it. Normality distribution. I also showed you how to look at the outliers. But as a part of independent sample t-test, something new we got it this time. Something new we got it. That is nothing but homogeneity of the variance. There are two new points. First one is we required two variables, dependent variable, independent variable. This is very clear. Second new point is that there should be homogeneity of the variance. What it is? I have two groups like male group, female group. I'm assuming that they're equally satisfied. They're equally satisfied. With the help of the homogeneity of the variance test, I'm going to check whether are they equally satisfied or there are differences. Okay. Just go to analyze. I'm not conducting a normality test because I have shown you in more detail how to conduct the normality test. Okay. Now, in order to conduct the independent sample test, go to analyze, compare means. There is option called independent sample t-test. There is option called independent sample t-test. As a part of independent sample t-test, what is our hypothesis? As a part of hypothesis, we have two variables. Gender is one variable. How I have given coding 1, 2. Okay. After selecting the variable gender here, we need to define the groups. I have given code 1 for male, 2 for female. Okay. Continue. My dependent variable is satisfaction. Other than this, we have any satisfaction, happiness. Let me take satisfaction here. Okay. Just click on OK. Just click on OK. Now look at here. First one is providing basic cross tabulation. I can say the basic descriptive statistics. Like it's talking about there are 50 respondents, 27 people belongs to male category, 23 people belongs to female category. When it comes to the satisfaction score, male respondents are satisfied 2.9%, female respondents are satisfied 3.01%. Okay. Now, I am not able to see any major difference, but in order to see are there any significant results, we need to conduct the independent sample t-test. Now, looking at the independent sample t-test, there are two tests are here. One is Levion's t-test, that is nothing but homogeneity of the variance. That is nothing but homogeneity of the variance. Here, as a researcher, I am assuming that there is equal variance between the male group and female group. I'm assuming that there is equal variance between the male group and female group. If my p-value is greater than 0.05, it means equal variance is assumed. If the p-value is greater than 0.05, equal variance is assumed. If equal variance assumed, I'll take the first row of the table. Imagine that if the equal variance is not assumed, in that case, I'll go to the second row of the table. Now, as p-value is greater than 0.05, I'm able to fulfill the assumption of homogeneity of the variance. Okay. Once I fulfill the assumption, I'll take the independent test result. Here I got result 0.051. What are the difference I got it here? Whether is this statistically significant difference? My p-value is greater than 0.05. It is 0.835. It means there is no significant difference between male and female satisfaction. They are more or less equal. They are more or less same. Okay. Now, whenever you are getting the significant results, we are going to talk about the effect size. But right now, our results are not significant. So there is no point of talking about significant results. Okay. Okay. So are there any questions? Still we have around 10 to 15 minutes time before going to next statistical test. Dear scholars, are there any questions? Please raise your hand or you can type your message here. Are you able to follow? Is it clear today's session? There are 175 people. Either you have to put message or you have to say something, say. If you don't have Soumya Mohan, okay. Dr. Manjula, okay. So you want me to take any of the questions or shall I go ahead with one more test, paid sample t test? We have still 10 minutes time we have it. Okay, let me go with one more test in that case. I'm sharing my screen again. This time I'm going to conduct paid sample t test. The main objective of conducting paid sample test is to compare between pre and post. Like for example, as you are a faculty member, you might be attending a lot of certificate courses, orientation course, refresh course, or you might be attending just like current program. And you want to see before attending this particular course, what is your statistics knowledge score? And after attending this particular course, what is your satisfaction? What is your statistics knowledge score? So similarly, in our data set, we have pre-counseling, post-counseling. Pre-counseling nothing but violations of prisoners before counseling. So some people came to prison. So as a jailer, I have given some counseling. As a jailer, I have given some counseling to my prisoners. So they went back. Before counseling, how many crimes they have committed? I have given counseling, whether they came back again. If they came back, how many crimes they have committed it. Like for example, is nothing but experimental research. It is nothing but looking at pre-test, post-test evaluation. Okay. So we need to have two results. We need to have two tests. It is not only meant for pre and post. Whenever you have two situations, for example, your daughter or son is bringing their mark sheet, progress card, not your daughters. As a part of your students, there are 6 papers. They might be having 5 to 6 papers. If you want to compare the difference between classical modern sociological theory marks with rural development or sociology of education, which paper measured students got more marks or less marks? I just want to compare two papers. Okay. Even in that case, whenever I have two situations, two incidents, two events, I can conduct paid sample t-test. I can also conduct paid sample t-test whenever I have pre-test, post-test type of data. Okay. Go to analyze, compare means. There is option called paid sample t-test. There is option called paid sample t-test. Here, violations of prisoners before counseling. I'm taking one variable. Second one, violations of prisoners after counseling. That is pre and post. Okay. Go to options, 95% confidence interval. Click on OK. So look at the result. Before giving counseling, the number of violations were committed were 21.28. Mean score is 21.28. After giving the counseling, the violations are 18.26. Now I can see some difference in terms of the mean score value. How much am I able to see the difference mean score? 3.02 difference. If I calculate 21.28 minus 18.26, I'll get mean difference 3.02. But the difference that I'm getting it, is it statistically having significant difference? For that, I need to see the p-value. My p-value less than 0.05. My p-value less than 0.05. It means there is a statistically significant difference between pre-counseling and post-counseling. There is a statistically significant difference between pre-counseling and post-counseling between the respondent. Now, as there is a difference between pre and post-counseling, I just want to know, instead of saying simply, there is a significant difference, I want to talk in terms of how much effect it is having it. Being a social worker, being a psychologist, or maybe in general, if you are bringing some kind of intervention, I just want to know what is the effectiveness of this particular intervention, whether it's 10%, 20%, 60%, right? Instead of simply I say, okay, there is a significant difference. But if you want to convince a layman, I need to put it is always better to put it in the form of percentages, right? So for that, we have a concept called effect size. There are so many scholars. One of the most prominent scholar is Cohen D. Let's see what he mentioned about it. Where is this? 1 minute. Yeah. Effect size. Effect size, if I am getting as a part of my statistical test result, if I'm getting less than 0.02, you can consider as a small effect size. If I'm getting a figure like less than 0.02 or between 2.5, between 0.2, 0.5, it is a medium effect. If it is between 0.5 and 0.8, it is called greater effect. But these particular points may not be help me, right? So what I will do, I'll convert in the form of percentages. If it is 0.2 means 58% effect. So as a layman, I can easily understand what exactly it means, 58% effect my intervention. If it is crossing 50% means I'm success in terms of the program that I attended, the kind of intervention that I given it. 0.5, 69%. 0.8, 79%. If somewhere it comes 1.4, it means 92%. So this is all about for today. And tomorrow I'm going to talk about ANOVA test, correlation test, regression test, and I'll also show you a couple of, at least I'll demonstrate how to you conduct a smart PLS. Tomorrow is going to be the third day of the SPSS. Whatever I covered yesterday, today, if you have any questions, maybe you can cover tomorrow as a part of the recap for the first 10 minutes, 15 minutes. If you have any questions, please practice it if you really wanted to learn something. Okay. And please install the SPSS software. Otherwise, you can't open this particular documents, sample data sets that are given to all. Okay. Thank you, Manjula madam. Thank you so much. Thank you all. This is Professor Jagadev. This is my third online workshop. Thank you, Professor. Thank you so much. If there are any questions, please let me know so that I can able to answer it. Otherwise, I'll request the organizers to end the session. Thank you. Thank you so much. Thank you.
Yes, sir. Thank you so much, sir. Thank you so much for completing day 2 of your session, sir. And dear participants, as per the notification, we are started by 6 and we are ending by 8 o'clock. Requesting you to join on by tomorrow on right time, 6 o'clock to 8 o'clock. Till that, see you and good night to everyone.